Salutations everyone, Dustin here. In this video, we will be doing mole calculation. Before anything else, no, it is not that type of mole that buries underground, just like this one, but rather a unit of counting in terms of chemistry. So, what is a mole? Just like a dozen represents 12, chemists use mole as a counting number. As atoms are incredibly small and there are a lot of them, an efficient way to calculate them is by using the counting measure mole. A mole is equivalent to 6.022 times 10 raised to the 23rd atoms. So just by hearing that, it's incredibly large. It's 6 followed by 23 more zeros. 22 rather. So let us begin. For our first question here, it asks, how many moles are present in 36 grams of water, or H2O? So the first step here is we calculate the molar mass of each element. So if you are familiar, the molar mass of hydrogen would be 1. And the molar mass of an oxygen, or O, would be 16. So given H2O, we will calculate it into grams. So 1 hydrogen is equivalent to 1 gram, and since there are 2 of them, H2, we multiply it by 2, plus the molar mass of oxygen, which is 16. We will have 18 grams per molecule. So step 2. Since we have 36 grams of water and for each mole we have 18 grams, we just do a simple equation here with, since we have 36 grams of H2O over 18 grams H2O molecule, we will get 2 moles. The answer here would be 2 moles. Moving on to the second problem. What is the mass of 3 mole oxygen? What is the mass of 3 mole of oxygen gas, or O2? So it's pretty much just the reverse version of the other one. Now it gives us the amount of moles, then asks for how many grams. So first things first, we take the molar mass of an oxygen, which again is 16, and since there are 2, we multiply it by 2, then we get 32 grams per molecule. Now, sorry, mole, not molecule. Anyways, since we have 3 moles here, and a single mole is 32 grams, we simply multiply them. So we have 32 grams per mole multiplied by 3 moles will end up with 96 grams. Simple as that. If you are given the mole, you may convert it into grams, and when you're given the grams, you may be able to convert it into moles. And so next question, how many molecules are present in 18 grams of water? So this just asks how many atoms are present in 18 grams of water. So first things first, we calculate the amount of molar mass we have here, and then we convert it into mole. So again, H is equivalent to 1, and oxygen is equivalent to 16 molar mass. H2O, 1 times 2 is 2, plus 16, we get 18 grams per molecule. Now we identify how many grams we have. Since we have 18 here, we could divide this. So 18 grams of this mole divided by 18 grams. Then we get 1 mole. So it says that if we have 18 grams of water, it's equivalent to 1 mole. Now it asks how many molecules or how many atoms we have. Since we already have 1 mole, we could just convert it into atoms. And if you could recall, a mole is equivalent to 6.022 times 10 to the 23rd amount of atoms. This is our answer. We have this much molecules in 18 grams of water. Moving on. A sample contains 2 mole carbon dioxide. How many oxygen atoms are present? Now in this question, it asks how many oxygen atoms, not carbon dioxide atoms. So in order to solve this, we must first determine the mole ratio. So 1 mole of CO2, we have here 2 moles of oxygen atoms. So we would write 2 mole oxygen atoms. And since we have 2 moles here, we multiply it. So we have 2 times 2 molecules of oxygen atoms. And our answer would be 4 moles of oxygen atoms. Then we multiply it by 1 mole. We basically convert it into atoms or molecules. So use this times 10 to the 23rd power, such a massive number, and we get 24.08 times 10 to the 23rd. And since we want to use proper scientific notation, we would move this to the other side such that we would only be left with 2.408 times 10 to the 24. So this would be 2.408 times 10. And since we moved it one side to the left, the period would be increasing this by 1. So this would be our answer. The amount of atoms present. Moving on. For the following chemical reaction, this one, N2 plus 3H2 converted into 2NH3. If 9 mole of H2 reacts completely, how many moles of NH3 are produced? Now this is about limiting reactants. Basically, what this asks for is if we have 9 moles of H2, how much could we theoretically make? How much at 2NH? How much NH3 could we make? So let's write it. As you can see here, we need 3 moles of H2. H2 would yield us 2 moles NH3. And it asks if we had 9 moles. So we just multiply this until we get 9. So 3 times 3, or 9 moles. We multiply this side by 3. 9 moles H2 converted. Now since we multiplied this side with 3, we also multiply this side with 3. So if we have 9 moles of H2, we'd have 6 moles of NH3. Simple as that. Now, I actually want you to solve this question. It's your time. So, a sample here contains 90 grams of glucose, or this one, C6H12O6, and you're tasked to find the number of moles of glucose, the number of glucose moles, and the number of carbon atoms. Just a simple way to guide you. You must first convert these into molar mass. Then, using this 90 grams, identify how much moles you have by dividing the 90 grams over how much you got here, how much molar mass. Then you have identified the amount of moles. After that, basically just convert it into atoms or into molecules. And for this one, for this carbon atoms one, you would want to identify first how many carbon moles you have, convert it into atoms. And that's pretty much it. You could drop down below in the comment section your answer for this. I would also leave the answer in the description. And hopefully you understand how to use mole conversion in the world of chemistry. So I'm wishing you all the best and farewell.